So in this video, I'm going to be walking you guys through all of the problems on page 12, and the answers are going to go into a Google form. And this video is really just meant to help support you if you feel like there's a problem that you're worried you're going to miss. So I'm just going to start right here from number 1. We're just ordering these from least to greatest, and it's going to be 8.3 times 10 million, 3.2 times 1/100th, 4.016 times 10,000, 6.98 times 1/1000th, and 4.045 times 10 to the 4th. So I want to remind you guys that if it's all scientific notation, you can simply look at the exponents and order them from least to greatest, and you'll be good to go. So -3 is smaller than -2, and at this point I'm going to show you guys the answers. There's the -3, then the -2, and then the right here with the 4s, the 4s actually tie. So you'll notice that the 4.016 comes first, then the 4.045, because right here the 1 is smaller than the 4. And then the 7 is the biggest exponent there. All right, so for the next part here, when we are looking at 10 to the -2, that's simply 1 over 10 squared. That's the inverse of 10 squared. So that's 1 over 100, which is 1/100th. There's your 2 zeros. For a percent to go to a decimal, remember if you're taking 25% and you want it to be 0.25, we're going to move the decimal back once, twice to the left. So this one, I move it back twice, and there's the 1.5. Now here, think about PEMDAS. In PEMDAS, you've got parentheses. GEMDAS teaches grouping symbols. So inside those grouping symbols for absolute value, we want -8 plus 10. Now -8 plus 10 is 2, and 2 is 2 spaces away, so the absolute value of 2 is 2. Now for this one, I'm just going to leave it as -315 because I've got decimal, decimal, that would be a 2.0, a -315.0. Now this next one is in scientific notation, and it's really just 2.05 times 1/100th. So if I want that back in standard form, I'm going to move the decimal back twice, and that's where I'm getting the 0.0205. And this last number, it's a percent, so I'm going to move the decimal back twice, and I'm really dealing with a -3.2. So now we've got all of the numbers written in standard form. And we're going to start with the negatives. And -315 is way smaller than a -3.2. So there's the -315 is smaller. This is -3.2. Careful, a lot of people are going to mix that up because they see a -320%. And even though it's a percent, some people are just going to see the -320 and think that it's the smallest number. But because that's really a -3.2, it's closer to 0. Now we've got this 0.01. This 0.1 right there is smaller than this 0.2. So that's why the 1/100th comes next, right here. Now I've got the number in scientific notation. Now my 1.5, so the 150%. And last but not least, 2 is the biggest number that we have. And notice I'm writing these answers in order from least to greatest in their original format. All right. Now for number 3. Once again, my goal is going to be to get them all in standard form, and I'm going to try to not have any percents involved. So I'm going to take this one and move it back twice, and I've got 0.135. How far away is -0.2 from 0? 0.2 spaces. This is already a decimal, so I'm just going to leave it 0.1456. Next, anything to the 0 power is 1. My number in scientific notation, to convert it back to standard, I'm just going to move the decimal back once to the left because that's what it says to do, and that's how I get the 0.145. And now 10 to the -3, that's 1 over 10 cubed, so that's 1 over 1,000, and 1/1000th as a decimal is the 0.001, okay? So now we've got some numbers to order from least to greatest. So for the decimals, 1 is smaller than 2, 1, 1, 0. In my 10th spot, that one is the smallest. So this is going to be the smallest number in my list, the 10 to the -3. There it is. Now after that, I'm going to look at the 1 and the 1 and the 1. Now I need to go to the hundredths place. So the 3 is smaller than this 4 and this 4. Okay, so that's where I'm getting the 13.5% next. Now the 1, 4, and the 5 tie. And if I put in a 0 as a placeholder, we can see that this one is smaller than the 1, 4, 5, 6. So my scientific notation number comes first, then the 1, 4, 5, 6 decimal. Then it's going to be the 0.2. And last but not least, the whole number, 10 to the 0 power 1, is going to be the biggest number in our list. So that takes care of the ordering problems from least to greatest. Yes, you can use a calculator if you feel like it'll help the math go faster. We've got shortcuts with the exponents up here. Down here, friendly reminder that negative numbers are always going to be smaller than positives. And another friendly reminder that a negative exponent does not mean you have a negative answer. It means you have a decimal. Now down here, to help see these answers, I've got things expanded out for you guys. So for number 4, the base is -5. And this negative times negative is a positive 25. But times a negative again is a negative 125. For the next one, number 6 in purple, it's not in parentheses, so it's 6 times 6, which is 36. Now the negative, negative 36. Now I did mention the vocabulary word, the radicand. We want to simplify negative 20 plus 45 first and get a radicand of 25. Now I can take the square root of 25 and get 5, but that negative out front is going to go with my answer, so -5. Let me back up real quick. If you're unsure of how I got 25, think about the fact that if you owed somebody $20, but you gave them 45, you gave them $25 too much. All right, and for number 7, to help you see it, I have it in orange. Again, it's just the number 1 times itself 4 times, and then the negative out front means that your answer is going to be negative overall. Moving on to number 8, we've got a -3 times itself 4 times. And y'all, that negative times negative, that's going to be 9. And now this negative times negative is 9. And you guys know 9 squared, 9 times 9 is 81. All right, for number 9, we want to ask what is 3/1000ths as a percent. And right here in green, I want to remind you that to go from a decimal to a percent, we move the decimal over to the right 2 times. So I'm going to move this decimal over to the right 2 times, and there's the 0.3%. Now we're on number 10. For number 10, 32 hundredths, I just said that decimal. Now it's a fraction. And we can divide both of these by 4 when we reduce. Now you could divide by 2 and get 16 over 50, and then divide by 2 again. That works. Or the greatest common factor, divide by 4, and we get 8/25. Now for number 11, I wanted to remind you guys, when you see 5 divided by 6 in a calculator, so 5 divided by 6 is the 0.8 with the 3's repeating. And so now if I move that over twice, it's going to be 83.3, and the 3's keep repeating. So you could have written 83 and 1/3% right there, but I highly doubt any of you are going to write the fraction 1/3. But there's the 0.3's that keep going forever. All right, now for number 12, we're just comparing using the alligator symbols or an equal sign. So just reviewing some elementary school basics here. If you subtract 63 from a negative number, it's going to get more negative. So you got 22 negatives and 63 negatives. You've got 85 negatives total there. Now if you're going to add to a negative number, it could still be negative. It might be positive. If we added 101, for example, that would turn it into +1. But here, we're only at a -72. And since -72 is closer to 0, that one is larger. Now, earlier in the school year, we had a warm-up where we talked about consecutive. Consecutive means just one right after another. So we're going to take the square root of 81, which is 9. And now I just want to ask you guys, on a number line, what two numbers is 9 between? There'd be an 8 over here on a number line, and then there'd be a 10 over here. So the answer to this one is 8 and 10. Square root of 81 is 9, and that happens to be between 8 and 10. All right, now between which two consecutive numbers would the negative square root of 9 be? So the square root of 9 is 3. Now, the negative out front means we're dealing with a negative 3. So if I ask you which two numbers is that in between to make consecutives, negative 3 is in between this negative 4 and this negative 2. So these are consecutive integers, and negative 3 would be between negative 4 and negative 2. All right. For number 15, for the long division here, I wanted to remind you guys about when you would need a 0 as a placeholder. So I've already got all the work here, and I'm just going to trace over it so that you can see my original problem is this 8 being divided by the 500 over here. Now 500 will not go into 8, so I need a decimal. 500 will not go into 80, so I need this 0 for that 0 right there. And now I can get going with 500 goes into 800 one time, and that's me subtracting the 500. I get 300 left over, and at this point it's okay to bring down this 0 to make it 3,000. And 500 goes into 3,000 6 times evenly, and since I get 0, I'm done. So one more time, 5 didn't go into 8, so I got the red decimal in 0. 500 still didn't go into 80, so I put a green 0 to bring in this 0. Now 500 goes into 800, and I can get going. So last but not least over here, I'm starting out, this time I've got 20 in blue being divided by my 300. Now because 300 doesn't go into 20, I need this decimal point right there. 300 will not go into 200, and that's why I need a 0 here to get this 0. Now I can ask myself, how many times will 300 go into 2,000? And it was 6 times to get 1,800. And then I can subtract to see that I'd get 200 left over. When I bring down my 0, it's 2,000, and I can see that my 6's are going to end up repeating, because if I had to bring down another 0 right there, that's going to be another 6 for another 1,800. So the purpose of 15 and 16 was to review with the long division. When you put the decimal there, if that's still not enough, you need to bring in a 0. Now these answers do go in a Google form, and I do have a video to go along with this. And so, in my opinion, this would be an easy 100 Google form. Now, if you tried this without the video, you might not have done so well, but obviously if you're still listening to the video, hopefully you'll do well when you put these answers into the Google form. And that concludes the video. Thank you.